Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going, refreshed, and inspired. And I'm very willing to share my knowledge, especially topics in civil engineering for your benefit. Determine the reactions at the supports B and C for the prop cantilever beam by superposition method. So here is the given figure. So let's recall the reaction at B as RB, R sub C at C, then RD, and moment at the positive direction as shown. Let's transmit the 120 kilonewton load at B. So that would be the effect. Then let's remove the reactions or supports at B and C so that it will deflect freely. So remember the deflection here is MO L square over 2EI. So therefore here, because if we transmit that 120 kilonewton here, the formula is the same but lesser because L is 6 in this case. So this is also MO L square over 2EI or MO A square over 2EI, where A is equal to 6. Then due to RB, by adding RB downward and RB upward at C, so we have upward at C and a couple which is 6 RB. So that's the deflected shape. Then this is RB uh, due to this RB here, push upward, RB L cube over 3EI. That's the formula if you can recall. Then let's transmit RB at C, which will produce RB upward and a couple. So by adding a pair of forces in equilibrium, RB downward and RB upward by principle axiom of mechanics, one axiom of mechanics. So the downward RB and this upward RB will constitute a clockwise couple of 6 RB, and there is still RB at C here. So it will deflect with a combined value of RB L cube over 3EI, and this is theta C. The angle here, the slope at C is RB L square over 2EI or P L square over 2EI plus moment L over EI, if you can remember. Then it will extend, the angle is theta C. So therefore, due to this deflection, RB and 6RB, it is RB L cube over 3EI plus moment 6RB L square over 2EI. So that's theta C. That's theta C also. So that's why this is 6 theta C, because this is 6 meters. And this value here is the combined deflection due to RB and couple 6 RB. So RB 6 cube over 3EI plus moment L square over 2EI. So moment 6 RB, L is 6 over 2EI. Then finally, due to RC alone, it will deflect with a slope of theta C, which is RC L square over 2EI. So that is RC L cube over 3EI. But the slope theta C1 is, let's solve it, RC L square over 2EI. So this vertical distance is 6 theta C1, that one, 6 theta C1, and this one is already known. So EI theta C1 equals RC L square 6 square over 2. So it is equal to 18 R sub C. So therefore EI theta C is RB 6 square over 2 plus 6 RB times 6. So that would be equal to EI theta C is equal to 54 R sub B. Then substitute all positive deflection minus negative deflection equals 0. Let's begin here at B rather. So RB 6 cube over 3, let's take EI1 plus 6 times theta C, which is 6 times 54 RB, plus RB 6 cube over 3 plus 6 RB 6 square over 2, then plus 6 plus RC 6 cube over 3 plus 6 theta B1, 6 times 18 RC, theta C1 rather, then minus MO 120 12 square over 2 equals 0. So simplifying, 576 RB plus 180 RC equals 8640. Call that equation 1. Then for the deflection at C, equate to 0. Let's begin with R sub B here. 6 cube over 3 plus 6 RB 6 square over 2 plus RC 6 cube over 3, then minus 120 6 square over 2 minus this equals 0. Combined and simplifying, 180 R sub B plus 72 R sub C equals 2160. So expressing R sub C in terms of RB, R sub C is negative 180 over 72 or negative 2.5 R sub B plus 2160 over 72, that's 30. Substitute in equation 1, 576 RB plus 180 times quantity negative 2.5 RB plus 30 equals 8640. From here, we can now solve RB. R sub B is equal to 25.714 kilonewtons. Then finally, R sub C negative 2.5 times 25.714 plus 30. So R sub C is equal to negative 34.285 kilonewtons. So that's it for this problem.